So today we're going to prove from first principles that the derivative of sine x with respect to x is cos x. So we know that from first principles the derivative of sine x is the same as the limit as delta x approaches 0 of sine of x plus sine of x plus delta x minus sine of x over delta x. Now we're going to use the compound angle formulae, which is sine of a plus b equals sine a cos b plus sine b cos a. So if we do that, we get the limit as delta x approaches 0 of sine of x cos of delta x plus sine of delta x cos of x minus sine of x over delta x. Now we can factorise the sine x out of the first and last term here, giving us the limit as delta x approaches 0 of sine x times cos of delta x minus 1 over delta x, and then we're going to add cos x and write this as sine of delta x over delta x. Now, to evaluate this limit, we're going to note that cos of delta x minus 1 is the same as minus 2 sine squared delta x over 2. So when we plug that into here, we get this is the same as the limit as delta x approaches 0 of sine x times minus 2 sine squared delta x over 2 over delta x, and then we add cos x. Now we know that the limit as delta x approaches 0 of sine of delta x over delta x is just 1, which I proved in a separate video, and so in fact we can just close this limit here and say this is cos x times 1, which is just cos x. So now we have this, we can write this as the limit as delta x approaches 0 of sine x times sine of delta x over 2 over delta x over 2. So we're just moving this 2 to the denominator of the denominator, and then we multiply by minus sine of delta x over 2, and then we're still going to add cos x. So from here we can make a simple change of variable if we let delta x over 2 equal h. Now as delta x approaches 0, then h will also approach 0. So this is the same as the limit as h approaches 0 of sine x times sine of h over h times minus sine of h. And then we add cos x. Now, we know that as h approaches 0, sine h over h approaches 1, and we also know that sine h approaches 0. So this is just going to be 1 times 0 times sine x, but 0 times anything is just 0. So this is going to become 0 plus cos x, which is just cos x. And so we've proved it. That's all for this video. Thanks for watching. If you have any questions or video suggestions, leave them in the comments below, and if you want to see more content like this, subscribe now.